Equations of tangent lines. The majority of this unit has been spent finding derivatives of various types of functions. We know derivatives represent the slope of a curve at any point P on the graph. Now that we are familiar with calculating derivatives, we can use our techniques to write the equation of the tangent line at any particular point P on the curve. Recall from algebra, one technique used to write the equation of a line is by identifying the slope and a point on the line. Therefore, to find the equation of a tangent line to a curve, the following is needed. First, we need a point where the tangent line touches the curve, and then we need the slope at that specific point. Let's try an example. Write the equation for the tangent line to y equals x to the third minus 4x squared plus 2 at x equals 2. In order to write an equation, we need the point and the slope. Well, we can find the y value for our point by substituting the given x value into the equation or the function. So we have 2 cubed minus 4 times 2 squared plus 2. We'll get 8 minus 16, that's negative 8, plus 2 is negative 6. So our point where we're going to have our tangent line is at 2, negative 6. Now to find the slope, we can calculate the derivative and substitute x equals 2 into the derivative equation in order to find that slope. So we have to calculate the derivative of y equals x cubed minus 4x squared plus 2. Its derivative is going to be 3x squared minus 8x. And then if we substitute 2 in, we will get 3 times 2 squared, or 3 times 4, which is 12, minus 8 times 2. So that'll be minus 16. So 12 minus 16 is negative 4. So that is going to be the slope of our tangent line. Now we have our point and we have our slope, so we can write the equation of the tangent line to be y plus 6 is equal to negative 4 times the quantity x minus 2. Write an equation for the tangent line to y is equal to 2 times the sine of x at x equals pi over 6. Begin by substituting pi over 6 into the function for x in order to find the corresponding y value of the point of tangency. If we do that, we're going to have y is equal to 2 sine of pi over 6. Well, the sine of pi over 6 is 1/2, and 2 times 1/2 is 1. So therefore, our point of tangency is pi over 6, 1. Next, find the derivative of the function. So y is equal to 2 times the sine of x. So y prime will be 2 times the cosine of x, because the derivative of sine is cosine. And then, when x is pi over 6, we can find the derivative at that point, which is the slope at the point of tangency. So if we substitute pi over 6 in for x, we'll have 2 times the cosine of pi over 6, which is positive square root of 3 over 2. If we multiply that by 2, we have positive square root of 3. So that is going to be the slope of our tangent line at the point pi over 6, 1. The final step is to substitute the values of x, y, and m into the point-slope form in order to find the equation of the tangent line. So we have y minus our y coordinate of 1 is equal to the slope, the square root of 3, times the quantity x minus our x coordinate pi over 6.